Hey everyone, and welcome to Topictrick, where we turn complicated ideas into understandable insights. Today we're continuing our journey into APIs, and in this video, we're focusing on the core building blocks that make any API work. By the end of this video, you'll have a clear mental model of how APIs are structured, how clients and servers communicate, and why each component exists. Let's start by thinking about what an API really is. At its core, an API is a contract between a client and a server. The client asks for something, the server responds, and both sides follow a shared set of rules. Those rules are defined by a few key components, and the first of those components is the resource. A resource represents a piece of data or a concept that the API exposes. For example, in a blog application, a resource might be a user, a post, or a comment. In an e-commerce system, resources could be products, orders, or customers. The important idea is that a resource is a noun. It represents something, not an action. To access a resource, we use something called a URI, which stands for Uniform Resource Identifier. A URI is basically the address of a resource on the web. You can think of it like a home address, but for data. For example, /users might represent the collection of all users, while /users/42 might represent a single user with an ID of 42. This address is often called an endpoint. An endpoint is simply the specific location where a client can interact with the resource. The structure of the URI helps both humans and machines understand what is being accessed. Good API design uses clear and consistent URIs. Typically, URIs are plural nouns and are hierarchical. This makes the API predictable. When developers can guess how a URI should look, they can work faster and make fewer mistakes. Now that we know what a resource is and how it's identified, the next question is how we interact with it. This is where HTTP methods come in. HTTP methods define the action the client wants to perform on a resource. The most common HTTP method is GET. GET is used to retrieve data from the server. When you send a GET request, you're saying, "Please give me this resource." A GET request should never change data on the server. It is read-only. Next is POST. POST is used to create a new resource. When you send a POST request, you are usually sending data to the server and the server creates something new, like a new user or a new order. Then we have PUT and PATCH. Both are used to update existing resources. PUT usually means replacing the entire resource with new data, while PATCH means partially updating it. In practice, many APIs use PATCH for small updates, like changing a user's email address. Finally, there is delete. Delete does exactly what it sounds like. It removes a resource from the server. When you send a delete request to a specific endpoint, you are asking the server to remove that resource. Together, resources, URIs, and HTTP methods form the foundation of RESTful APIs. The URI tells us what we're working with, and the HTTP method tells us what we want to do. Now let's move on to the next set of components: headers, query parameters, and payloads. Headers are key value pairs that provide metadata about the request or the response. Metadata is information about the data, not the data itself. For example, headers can tell the server what type of data the client is sending, what format the client expects in return, or who the client is. A very common header is content type. This header tells the server what type the request body is in, such as application/JSON. Another important header is authorization, which is often used to send authentication tokens so the server knows who is making the request. Headers are powerful because they keep concerns separate. Instead of mixing metadata into the main data, headers handle things like authentication, caching, and content negotiation in a clean and standardized way. Next are query parameters. Query parameters are added to the end of a URI and are typically used to filter, sort, or paginate results. For example, you might request /users page equals 2 to get the second page of users, or /products category equals electronics to filter products by category. Query parameters do not change the identity of the resource. Instead, they modify how the server processes the request or what subset of data is returned. This makes them ideal for searching and filtering. Now let's talk about the payload, also known as the request body. The payload contains the actual data being sent to the server. Payloads are most commonly used with POST, PUT, and PATCH requests. For example, when creating a new user, the payload might include the user's name, email, and password. This data is usually sent in JSON format because JSON is lightweight, readable, and widely supported. It's important to remember that not all requests have a payload. GET requests typically do not include a request body because their purpose is only to retrieve data. At this point, we've covered how requests are structured. Now let's look at how servers respond using HTTP status codes. HTTP status codes are 3-digit numbers that tell the client what happened with the request. They are grouped into categories based on the first digit. Status codes in the 200s indicate success. For example, 200 means the request was successful and everything worked as expected. 201 means a resource was successfully created, which is common after a POST request. Status codes in the 400s indicate client errors. These mean that something was wrong with the request. For example, 404 means the requested resource was not found. 401 means unauthorized, which often indicates missing or invalid authentication. 400 means bad request, usually due to invalid data. Status codes in the 500s indicate server errors. These mean the request was valid, but the server failed to process it. 500 is a general internal server error, indicating that something went wrong on the server side. Using correct status codes is a best practice because it allows clients to understand what happened without parsing response messages. Well-designed APIs rely on status codes to communicate clearly and consistently. Now let's briefly talk about some best practices that tie all of these components together. First, keep your URIs simple and intuitive. Use nouns, not verbs, and let HTTP methods describe the action. Second, use headers for metadata and configuration, not for main data. This keeps requests clean and easier to understand. Third, use query parameters for filtering, sorting, and pagination, not for changing data. Fourth, always return meaningful HTTP status codes and clear response bodies. This helps developers debug issues quickly and integrate with your API more easily. To wrap up, APIs are built from a small set of powerful components. Resources represent the data, URIs identify those resources, HTTP methods define actions, headers and query parameters provide context and control, payloads carry the data, and status codes explain the outcome. Once you understand how these pieces fit together, working with APIs becomes much more intuitive. In the next video, we'll build on this foundation and start looking at real-world API interactions and examples. Thank you so much for watching the video.